All right, well, I'm friends with a lot of the people in this room. I was not so long ago on that side of the stage at LensFest last year and have been lucky enough to wriggle my way up here. But my name is Nick Ross. For those of you that don't know me, I'm a design engineer here on the product team at Snap, so same team as Alessio. But what I do is focused on prototyping and designing inputs and interactions for specs. So I do some production work on Spectacles Interaction Kit, but most of what I do is actually before we push features into SIK, concepting out prototypes, trying them with user research, validating ideas, and then if we get those approved, then working with the engineers to actually get these things into SIK. So a lot of the work that I do for SIK is kind of simultaneously under it and what feeds into it, but also from the outside, and I use it a lot as a user. And so there's a lot that I've learned through the time of using it, and would love to share that with you guys here today. So, without further ado, let's get started. We have a lot to go through, so I'm going to try to be pretty quick, and I want to do a Q&A at the end, so we're going to try to hit this with some pace. So we'll start fairly simple, just talk about the high-level overview of SIK, various events, and some little quirks about SIK in terms of our trickle-down and bubble-up architecture. Then I'll get into some of the specifics in terms of tips and tricks, how to use near fields, some utilities you might not know about, filtering principles. We'll do a crash course on signal processing. And at the end, we'll get to the exciting stuff, which is how to actually build on top of and extend SIK to create your own functionalities without kind of kicking yourself later down the line. All right, let's start with SIK structure. So what is SIK? As everyone in this room should know, it's just a package in Lens Studio. This is all TypeScript code that is fully exposed to you. There's nothing we're doing in SIK that is not something you could do yourself. Part of the principles with building this is that it's something you can do, and we're using totally open APIs. We're not using anything under the hood. We obviously do work with the engineers to get things on the system level exposed to us, but those all get exposed to you as well. So, there's a few special important folders here. They're pretty self-explanatory. Assets is everything that's not code. Core is the core stuff. Components is individual pieces you're going to use. Prefabs is probably the one you're most familiar with, because that's where the SIK prefab is that you drop in your scene. But what I mostly want to talk about is this utils folder, because I have learned over and over and over again that it is full of juicy, useful utilities that I have found myself rebuilding over and over again. But we'll get more to that later. Now, there's this other folder sitting within components of UI, and we've got pinch button, scroll bar, slider, toggle button. These are all deprecated. Don't use these. We're keeping these in here for now because we want you to be able to update SIK without your projects breaking in case you're using the old interactables. But these will not be visually updated. If anything, we might take them out in a future release. When it comes to buttons and how we actually implement things, we highly, highly recommend you move over to UIKit. So the reason we're in this situation at all is because we made SIK before we made UIKit, and then we decided to make a much more comprehensive suite of UI tools. And we needed something in the interim to actually show that SIK is useful and make interfaces. So that's why we have these. But UIKit is going to be consistently updated with our new design system. One of the magical things about this is if you use UIKit without modifying it too much, then you can update your package later if we do a whole new design system 3.0 or something like that. And the entire look of your UI will update to match the system, which is great and very powerful. If you use pinch buttons and everything that's in SIK, that will not happen, and everything will end up looking pretty old and antiquated, and then maybe eventually drop out of your project. All right, now, the SIK prefab. This is what you drop into your project, and you should all be intimately familiar with it. But in case you're not, it's not actually that much. Everyone internally here is a big fan of programmatic instantiation, so we try to populate the scene kind of with as little as possible. We give you what you need, and everything that you don't need to be touching or modifying will be instantiated at runtime. So, in the core, we have very basic your config, which will be your log levels, and whether you want to use debug visuals or not. And then you've got all your interactors, left hand, right hands, mouse, mobile. We'll talk about making your own interactors. Then you've got visuals. You can turn these off entirely if you want, but we've got hand mesh visuals and the interactor cursors. Both of these are going to see a lot of updates over the coming months, but generally speaking, you can leave those on. And then connected lenses for those of you who have tried hard mode. All right, if you have looked through our documentation, you have probably seen this diagram. We won't get too much into it, but I mainly just want to architecturally point out that SIK is at a macro level divided between interactables and interactors. So you can see over here we have interactables, and they coordinate through the interaction manager. So all the interactables and all the interactors will register themselves with the interaction manager and coordinate everything that way. And when you want to build custom behaviors or you're dealing with events, these are the two elements that you want to be aware of. Everything else in here you don't really have to worry about unless you're building things that are specific to the type of interactor. So for example, you don't need to know about the object tracking 3D for the hand input data if you're building something that doesn't involve the hands in some way. But if you do want to involve the hands, then it's good to know what kind of interactor you're dealing with. All right, let's talk about events. So you have also seen this if you've gone through our documentation and our SIK overview. You don't have to be deeply familiar with everything going on here, but once again, this kind of shows the interactor, interaction manager, interactable approach that we're taking, and these are all very basic, but I want to make sure you're all familiar, we're on the same page with what events are available to you. So that's all those guys on the right with the little loudspeaker. On trigger canceled, on hover exit, on hover enter, on hover update, on trigger end outside, on trigger start, on trigger update. Right, and so these are kind of what all of SIK is built around, and you want to use as many of these as possible to make your UI and your applications dynamic and responsive. Right, if you're not using any hover events, you're missing out on something that is potentially really nice for your users. Now, to the first thing you probably don't know. I realize most of you probably knew all that already. Trickle down and bubble up is this system we use to give ancestors in the hierarchy priority over their children, right? So let's say I click on this target interactable. I think it's event dispatcher, which we'll get into, will look at the entire hierarchy and then essentially pass the events through all of the ancestor trees to the target with the target listed in there. So the grandparent and parent can choose to do nothing with it, but if they want to interrupt it or trigger their own events, they can. And so this is really valuable if you're trying to build interactions within the hierarchy structure. Like let's say you have a frame with some buttons on it, and every time you press a button, you want the whole frame to change color or do something or just be reactive in that way, or like listen to that frame without having to listen to every single button on it, then knowing that this happens is valuable. And on the flip side, events bubble up as well. So after they've made it to the target, they will then go back up through the tree all the way to the grandparent. So you can kind of get this from either side, depending on what's useful to you. Realize that's vague. If you're curious about exactly how that works or exactly how you can use it, then this is the file you'll want to look through. It's right next to the interaction manager. It's called the event dispatcher. And there's some comments at the top, and it's pretty clear. I personally don't end up using this too much, but if you're using complex trees, this is the place to go. Section 1. Thank you guys for sticking with me. Now, on to the rest. Let's talk about near field. So can you raise your hand if you're familiar with what near field is and what the interaction plane is in Lens Studio? A few, okay, maybe a third of you. So for those of you that aren't familiar, our raycasting algorithm right now in the public version of specs is kind of cumbersome. You have to kind of hold your hand up here, right? And if you have a panel here and I want to point to that, it becomes very quickly uncomfortable. And to have something where I have a tablet right here that I want to interact with, but I have a ray that's going at an angle, is not particularly ergonomic, not particularly intuitive. So as one solve to that, we've come up with this idea of near field targeting. So essentially, we can set specific interactables as having an interactor plane. And if they have that, then when your hand approaches that, we'll switch the far field targeting. And when I say far field, that's the general raycast, right, when you're far away from it. We'll essentially transition that over to a near field. Now, we've tried a couple approaches with this. One where it kind of just lerps between the two. Currently, it's on a fade. The actual details of this are likely to change, but the fundamental concept of having conditional far and near field behaviors is definitely here to stay and is highly useful if you're doing anything with panels, right? So frames from UIKit are kind of the easiest way to use this. If you're making a flat UI, then you're going to want to use a frame, and at the bottom you can enable the interaction plane, and then automatically at runtime you'll have your interaction plane instantiated from SIK, and all of this will be handled for you. You don't have to worry about it. If, for some reason, you're making something that you want to change the targeting behavior, but you don't have a frame, then you can just use the interaction plane directly, and you don't have to worry about that. So what does it look like? This doesn't come through particularly well on video. The easiest way for you to see this is to put your specs on and pull out the little settings panel, and then move your hand into it and see the cursor move. But here you can kind of see as the hand moves away, this cursor is going to kind of jump to a new spot, right? That transition right there is the transition from far and near field. Like I said, we're going to make this a little smoother, but the concept itself is highly useful and something you'll want to use. So good to be aware of. All right, now let's jump into utilities. We are going to get out of the slides and into Lens Studio. So I've put this little project together for us. It is very simple. Right now, we just have a little box. And there's nothing going on here. So you see we have camera, lighting, spectral interaction kit, totally unmodified, and a box, which is a render mesh visual with nothing on it. Now that you've been introduced to Boxy, we are going to kill him. And go to the next one, box, world camera. So when I talk about valuable utils, I am literally talking about inside a spectacles interaction kit. Oh, here's the event dispatcher, by the way. This folder, utils, has all of these beautiful files. The reason I'm going through this at all is because, like many of you, I've come from Unity, and there are lots of functions in Unity that are just conveniences and great to have and finds components in children and things like that. And then you get to Lens Studio and you're like, oh, I always do this like this in Unity. And then you can't find it, or it's not built into Lens Studio. And then you're like, oh, OK, well, it's not actually that complicated. I can do a tree search or whatever. I can have Claude make it. No problem. And then you build it out yourself. And then, if you're me, you realize, oh, a month later, SIK had this the whole time. We've taken a lot of those common utilities and a lot of those things that just are useful and come up all the time and built them into SIK. For one, because they were useful in the building of SIK. But for two, to make them accessible to you and do a lot of that work of taking utilities that we can't bake into Lens Studio and just quickly make them accessible to developers. So I'm not going to go through all of these here today. There are way too many. But I highly recommend just scrolling through here or asking Claude, hey, make me a list of SIK utilities. What is available to me? And just understand that. And I know, especially given Alessio's last talk, you're like, well, do I actually need to know them? Claude will know them all for me, right? He doesn't yet. I don't know exactly why, but he does not look through all of your files. And he will also rebuild these functions without checking. So it's really useful for you to know them. There's all kinds, but I'm just going to go through a couple examples of useful ones. So the first one I actually want to talk about is the logger. So a lot of you probably are just using prints to get logs, but there is this really valuable thing in SIK that is the logger. So we're going to edit. I've just got our Boxy world camera. He's got a render mesh visual, and then this script. And in here, there's not a whole lot going on, but the first thing I want to point out is we're importing native logger from SIK, utils native logger, and then we can create a new log and just call world camera example. And we have our on start. We say if we have a camera, then log I. So info level log found world camera, right? And if I run this right now, I'm not going to see any logs. I mean, I'm going to see the SIK version, but that's it. I don't see my log, which seems like a bug, but it's a feature. If I go to Spectral Interaction Kit and turn the log level to info, when it was on error, all of a sudden, I see my log, which is great. Now, this might seem a little annoying, but for those of you that are more seasoned engineers, you'll know that this is actually really, really, really nice. Because if you have a ton of logging going on, you don't want to have to strip your logging out of everything that you make, right? You want to be able to, when some bug comes up, go back through your logs and see what was happening without having to put them back in and then take them out, put them back in. But also, if you're just using print statements and you leave them all in, you're going to have this like crazy, messy logging, and maybe you're going to start tagging your logs so that you can search for them. This just does that all for you. It's filtering your logs by level. It also, you'll notice that in this log, we have world camera example. I did not put that in here. I just said log.i, and it automatically prefixed it with the name of the native logger. So this is just really useful. Please do your logging this way, or instruct your agents to do it this way. It will make your life better. But if you're not seeing your logs, remember, you can always change this. Anyways, we will go back to info, because we're going to use a lot of info logging. Now the actual function that we're using. This is one I do all the time. Camera.getSceneObject. And the camera from world camera provider. So, or world camera finder provider. So this lets you find your camera. Nothing special here, but useful to know, and something that I did not know about. All right, SceneObject utils. This is the one that I have rebuilt the most times without realizing that we have it. There are all kinds of scene object utils. One, the one that got me to want to bring this whole section in here, find all components and children. This is here. It's for some reason not in native, our native TypeScript and in Lens Studio, but it is in SIK. So that's there. I recommend, going to scene object utils and scrolling through all of the beautiful utilities we have. But you can see that, if I put this in here, it will print I found 0, render mesh, visuals as my children. If I duplicate this and make it its own child, and maybe disable the other one, I should see found 1 child, right? Because there's a render mesh visual on this. All right, let's get away from the boring stuff and on to the more fun pieces. All right, so those two, I did programmatic access to utils, right? We also have plenty of utils that are not necessary. You don't necessarily need to programmatically use them. You can just add them in your scene hierarchy. One being headlock. My box follows me around. This is a super useful behavior. I find a lot of people doing all kinds of tricky, crazy things in the hierarchy and parenting to your camera object or trying to use screen space when sometimes just having a headlock is really nice. So we've got that. We've got billboard, very similar. This one, instead of moving it around, is just going to have it face me. And I can do this axes constrained, right? Right now it's only doing y-axis, so I can still see the top of the cube. If I turn all of these on, I'm not going to see any of the cube. It's just going to look like a square because it's following me everywhere, right? Up, down, yeehaw. State machine, this one's fun. For those of you that appreciate state machines, check this box out. All right, it just spun, it grew. It's doing all kinds of things. It's spinning, small again. You can see in our logs entering idle, entering rotating, entering scaling. So state machines are just very useful in all kinds of state logic, and I find myself building my own state machines all the time. We have an abstract state machine that you can use. You can create state machine, name it whatever you want, and then add state, and then just add whatever functionality within that state. All of what was happening there of just a cube doing all kinds of different transformations is happening within these few lines, right? We have one state that is idle, and then after 2 seconds enters the rotating state. Then after 2 seconds enters the scaling state, and while it's updating, does some local rotation. Same thing here, set local scale, and then enters back to idle. This is very basic. We have on enter, on exit, on update, but it's just a useful thing that you don't have to build out, especially if you're doing it over and over and over again. All right, last one I want to talk about, animate. We live in a very interesting Lens Studio world where we're in TypeScript, so we have a bunch of web dev conventions and things like tweens, which are not a thing in Unity, right? But they are useful if you want to do complex animations, but sometimes you don't need to. Sometimes you just want things to spin around, you just want them to move, you want to use you don't want to import a whole package that is doing all of this tweening. And so, on start, I have this thing spin a circle around. It's very simple. I can use animate and cancel from Spectacles Interaction Kit, create an event on start, and then I do, you always want to have your cancel subscription so that when you destroy, you can close it, and then you just define what do I want the animation to be, what do I want the duration, and during update, what do I want it to do. This is all very basic, but it allows you to not, deal with all of tweening if you don't want to. All right, filters. Filters crash course. We're going to talk about this crazy page. Woo! All right, so I have a computer engineering background, so this holds a special place in my heart and is something that I do daily here. It's not something you have to do very often, but for those of you that are interested in really pushing the envelope and building new controllers or building new kinds of interactables or really pushing what HCI can do and how we interact with things, you're going to have to deal with the fact that we have 4 very small underpowered sensors on this thing that are noisy, and we're doing some filtering for you. But if you connect some Arduino with Bluetooth or you're trying to make some controller, all data is going to come through noisy, right? Even human data comes through noisy. Actually what we do is not perfectly, we're a whole crazy biomechanical robot. The core piece we want to do is smooth things out. The reason we filter is, for one, we're getting noise, right? And we can generally define this computer-injected noise as high frequency. And this is generally true because this machine is trying to guess where your hand is, 100 times a second, 90 times a second. And it's going to be a little bit wrong every time, but it's going to be wrong 90 times a second. And so it's going to be wrong very fast. On the other hand, human motion is very slow. Even if I move my hand very quickly, I'm doing this, 3 times a second, right? Like 3 times a second versus 90 times a second, that's fine. If we could separate this on the frequency spectrum and just look at what is happening at low frequencies, we'd be able to separate what is the human data versus what is the machine-injected noise, right? And that's like our signal and noise separation. That's the whole point of filters. Now, the easiest way to do this is moving averages. So I'm going to just show moving average here. If you haven't picked up what's going on here, this little cross is what I'm doing with my mouse. That little jumpy thing is what I'm doing with my mouse with some noise injected. We've got a 50% signal-to-noise ratio right now. And then that little red dot is a moving average that is showing what if I take a moving average of the time series. If you're not familiar with the moving averages, it's pretty self-explanatory. We're going to take every sample and average them together and see what the output is, right? So the problem with this is you see how laggy it is. If the mouse on my computer was that slow, that would be completely unacceptable. If the interactables in your scene were that slow, that would be completely unacceptable. Now, a moving average from a mathematical perspective is near identical to a low-pass filter, right? When I say low-pass filter, if you're into music, this is like the bass, right? The low frequencies being passed while the high frequencies get shed, which is great because the high frequencies are what we defined is where our noise is, and the low frequencies is where the meaningful human data is. And we want to separate these, and it's great. We are separating it, but we're not doing it quickly enough, right? So what do we do? Well, we could filter less, right? We could take this moving average filter and say, like, OK, let's just look at, now it's faster, but it's not doing much filtering now. It's jumping around. We don't like that. So what do we do? Well, some very smart folks invented the €1 filter. And this has some funny origin. I think there was some 1-cent filter, and then some guy in Europe went, screw you, I'm doing the €1 filter, and I'm calling it this. So now you can see just how much more responsive it is. And this is kind of amazing. And it's like, OK, how are we doing this? How does this work? It's actually remarkably simple. So the €1 filter is taking a low-pass filter, which is just allowing that low-frequency motion through. But if we just had the low-pass filter, we would be doing what moving average is doing. But then we're moving that threshold of what frequencies we allow through based on how fast our target is moving. So that's kind of what these two parameters are. Just ask Claude how to tune this filter if you want. But I'm going to set it to 0, and you're going to see that they actually behave pretty similarly, right? When I set the cutoff frequency, which is very similar to this window size on the moving average, and now we're seeing lag, right? Because we're only letting specific frequencies through. But if I reset that, now I see my responsiveness again. So it's got to come at a sacrifice, right? So if we look at our graph at the bottom, it's showing us our errors, right? So you can see our purple line compared to our black or white line is pretty separated during those areas of big movement, right? And the reason is that we're allowing a lot more noise through when we see big movements, right? But this doesn't matter from a human perspective because us humans care a lot about accuracy when we're staying still. But we don't care nearly as much about accuracy when we're moving fast. When we're moving, we care more about responsiveness. So this filter is kind of a stroke of genius that allows a very simple equation to compensate for what humans care about actively. So what does this mean for Lens Studio? What does this mean for my projects? Well, one of the great things implemented into SIK in the utils, believe it or not, is a €1 filter. Wow. So this is not, like I said, it's mathematically not crazy complicated. There's not a whole lot going on here, but it's more than you want to implement on your own. This allows us to do all kinds of things. So the actual implementation is very easy. It's these parameters. Like I said, I'm not going to teach you how to tune parameters right now, but the internet is a wonderful thing. But let's see what we can actually do with it. So I'm going to take this little box here, and we're just moving back and forth, right? Why are we moving back and forth? OK, well, let's read this magical script. So €1 filter example. This is the only thing on our scene besides the render mesh visual. We are defining a filter. We are creating an update event. We're getting our time. And then we're defining noise factor, amplitude, frequency, and then we're creating a position. This is the magic line. Can you guys all read that? Yep, great. OK, so we're creating a vector 3, math, sine. This is split into 2 parts, right? OK, on the left here, we're trying to create a position. We're driving the x variable, so just that movement, with sine of time, frequency, and amplitude, right? This is very simple. This is just making a nice, even sine wave with no noise. And then we're adding to it math.random times a noise factor, right? So we're injecting noise. Right now, that noise factor is set to 0, so we're just going to see nice, smooth movement, as we would expect. If I set that noise factor to 1, we're going to see really ugly movement. And this is what you're going to see if you ever hook a sensor up without doing filtering on board. And you do want to do filtering on board, on board whatever your controller is, but it's never going to be perfect, and it's good to have scene contextual understanding. So now, if we look at what's actually happening here, we're doing this.transform.set local position, and we're using the noisy position. But we also have this smooth position, which takes our 1 euro filter, .filter, and then runs it through with these parameters. And I'm just going to switch our transform to use that instead of the bad one. And just like that, we're back to mostly smooth motion with a very noisy input, right? And this is kind of the magic of it. So I'm not showing you a particularly practical example, but you don't need to look much further than SIK itself. Our interactable manipulation, which is the component that lets you actually move things around, uses a 1 euro filter. Our cursor uses a 1 euro filter, and under the hood in the actual firmware of the device, we're using various manners of 1 euro filters to get all this done. There are a million places. Now, onto the fun part. SIK extensions. This is probably the most useful part of this presentation. So if I want to do something other than what is done in the SIK examples, which is hopefully all of you, because examples aren't going to sell spectacles, you are going to need to actually do something with our interactables. So just to show you, we have a couple, I put a box in here that is interactable color feedback. And this is a native SIK component. There's nothing special about it. If I hover over this box, then it takes one of those hover events and does something. If I click it, it changes the color. This is very, very simple script. There's nothing I've done here. I just want to show you that this is what we expect. But it also shows you that we can essentially make custom behaviors. That's like the primary way to integrate with these. And remember, we are split between two pieces in SIK, the interactables and interactors. Excellent. When it comes to interactables, these are not extensible classes. You cannot just make a interactable that inherits from our base SIK, and you do not want to edit SIK. The reason you do not want to edit SIK is because we are working on a dev kit, we are pre-launch, and we are going to be making a lot of changes to SIK, if I have anything to say about it. And so you want to be able to get those changes, those evolutions, those improvements without having to pull your hair out over some custom extension that you built because you built it into SIK. The ability to go into Lens Studio and do what I've done here and unpack SIK, but you don't really want to do that because you're going to run into this issue where you can't update it. And seriously, take it from me. I've been at a company that used the SteamVR SDK and chose to modify it, and then we were stuck 3 years in the past with no overhead to actually be able to update everything, and it was terrible. You don't want to be in those shoes. So don't edit SIK, but you do want to be able to extend it. So when it comes to interactables, behaviors are the way to do it, where you build on top of the events and triggers that are already built in without actually extending. But when you want to make custom interactors, you could do it that way. But most likely, if you're making an interactor, there's so much more custom logic than just what the events are. So then you can use a more extensible pattern where you're actually taking our interactor base classes and extending them. So let's talk examples. The first case, where we just want to modify what's happening. Here, we have our color changing cube. In the middle, I have one called snap grid. So this one just has interactable manipulation, and then it has snap to grid behavior, which is a very, very simple script that is just going to set up some callbacks and then do on manipulation, translation ends, snap to grid. So the thing I'm trying to show you here is actually that you don't even have to do it on the interactable. You can do it on pieces that deal with the interactable, which the interactable manipulation is. So this will wait for manipulation to end and then snap it to a position. So I can do this. This is very simple, right? But when I drop this, it's going to snap to a grid. But I just want to confirm with you all that that is the way you want to do things. Now, this next one, box cooldown, is a little more interesting. Let's say I want to make something that I can only interact with once every 10 seconds, right? So this, I can hover over, I can click it, but once I do, after my first interaction, I'm just not going to be able to do anything with this anymore, which is kind of expected, right? Now, as you probably expect, this is very, very simple. I'm just going to look at interactable, trigger ends, start cooldown, and then I'm going to start a timer. And on update, I'm going to check if the timer has elapsed or not, and if not, I'm going to set interactable enabled to false, right? This is not even extensibility. This is just like very basic hooking into events. This should be fairly boring for most of you. Now, the more fun one. If I want to build my own interactor, things get a little more complicated. But let's check out this gaze interactor. So I thought, OK, what if I want to deal with, and actually let me put our boxes back. I don't recommend from a usability standpoint that you guys deal with gaze interaction. But when I say gaze interactor, I think most of you understand what I mean, which is why we're using it as an example today. I want to look at something, and I want to hook into SIK's whole interaction stack and everything that we've built for you without having to do all of that custom. I want to make a special interactor. So I can create this class that extends base interactor. You can go in here and see what you need to do, but you are going to have to create, because it's the contract of the base interactor, to create all these getters that will return various pieces of information, but ultimately, the main thing is here in update state, right? This is going to get called by our main interaction manager, and you can put whatever functionality you want in here, including getting the main camera, casting, and seeing what you hit from the raid cast of the main camera. And so then, I can just look at these bad boys, and they turn on. Look at that. Incredible, right? And the magic of this is that, yes, this is a lot of code. It's 200 lines. But with the power of AI, it shouldn't be that hard. Then you can fully hook into SIK. And because I've done this, I've made this file outside of SIK. This bad boy, this gaze interactor, exists right here. Then when I update SIK, it will still work, right? As long as we didn't change the fundamental interaction paradigm or base classes, which we would be stupid to. Why not, for fun, since we're here and we have 9 extra minutes, let's take the risk of a live demo, why not? Sorry, you don't get to see yourselves, but you do get to see our magical 3 boxes. And very nicely, so you can see that guy snaps when I use my hands. You can see the little hand glow. And I'm purposely not looking at him, but if I look directly at him, hey, check that out. If I look at this guy for long enough, and the way I have this gaze interactor working is on a timer, so he's going to get stuck to my face, which is kind of expected. And then this guy, is going to do that and then probably turn off because he resets. Actually, he's still working. That's shocking. Anyways, there you have it. The live demo works. Huzzah. All right. Thank you all very much. That has been Advanced SIK. I know it's not crazy and there's not too much to it, but SIK is not that crazy. It's just something that is meant to be as nice to you as possible to make your jobs as developers as nice as possible. Thank you very much.